Hey, what's up, guys? We're going to basically be converting a nitrile into an amide. And so if you don't know what a nitrile is, it's basically just a cyano group, which is CN. It's going to be bound to an alkyl group. So in our example we're doing right here, we have a CN right here, and it's bound to this alkyl. So what we're going to do, we're going to form it into an amide. An amide is basically just, you could consider it like an ester, but without the O. But this is the N. So it could be like here, it could be with an H, whatever. It's going to look something like that. Okay, so let's start off with the equation. Let's start off with the mechanism. And so we have water. We have a lot of water in the flask, and we have H2SO4. Honestly, I don't even know how this happens, but we end up forming hydronium. And so let's just write it. Let's just draw the mechanism. Okay. We're in acidic conditions, so this means we cannot form a. We can do this equation. We can do this basically under acidic and basic conditions. Forget even all that. I don't want to sound complicated. If you're under acidic conditions, that means you can't form a negative charge. Basically, if you're doing the entire mechanism, you should never be able to. You should never see a negative charge in it. But since we're in acidic conditions, we'll only see positive charges. So let's say we used water, right? If we just use water right here, and then we did nucleophilic addition or something like that, we pushed it, we're going to end up forming a negative charge. So we're going to use hydronium. Hydronium is formed when you add these two together. If you see these two together, hydronium is formed. H2O and H2SO4. And so, okay, now we can get into the mechanism, right? Who's gonna do the attacking? Or you can ask the question, who is more basic? Nitrogen is more basic. So nitrogen will be attacking this. It's gonna be deprotonating. I don't even know what it's called. It's called acid base, but we're gonna get the H there. So right here, we're gonna be forming uh we're gonna be forming a delocalized charge. And so if you form a delocalized charge, that means you can do resonance. And so we're gonna push electrons towards the positive charge. So push this right here, pH. We're SP, so don't mess up like the drawing, right? You might get points off for that. So just draw it like this. And now carbon, basically this whole entire thing we're activating the carbon. I don't know, in the other examples we were activating the carbonyl, but right now we're just making it like activating it, or let's making it reactive. We're basically just making it reactive. Don't make it complicated. Just making it reactive. Okay, we have this like attractive, like not even attractive, it's more like reactive, like it's super, like it's just reactive. And since we have water in the flask, water itself isn't reactive, right? It's water. I mean, we could drink water, it's chill. But since this is super reactive, it's really like attractive to attack it. So water is going to attack this carbon. And so water is going to be doing nucleophilic addition. I'm I'm going back to, okay, so now we can go back to like normal drawings. Okay, so now what? Now we're going to be forming an oxonium ion. And so how are we going to like, obviously an oxonium ion, anything, every time you have a charge on an atom, it's not good. So how are we going to deprotonate it? We're going to deprotonate it with what's excess. So what do we have a lot in the flask? We have a lot of water in it. So water is going to be deprotonating this. So now we have a neutral, like I think we could call this intermediate. And so what does that go, right? We want to form an amide. So now we have this thing right here. We have an amide. Right now we have something called, honestly, I don't know what it's called right now, but it's something. Okay. Let me just draw this right here. Let me just copy it. Okay. Now we formed hydronium right here, right? But before we even do anything, we want to understand what's going on, right? We don't want to we don't want to guess who's attacking. Like when I'm imagine you're doing this mechanism, like you have the question right now, right? Who is gonna be, is nitrogen gonna be attacking the hydronium, or oxygen is gonna be attacking the hydronium? I mean, first off, you want to be forming an amide. Amide usually, I mean, in this example, we're gonna have two hydrogens on it, but forgetting even all that, we want to ask the questions: who's more electronegative, oxygen or nitrogen? Oxygen is more electronegative. It's more. In simple terms, if you're more electronegative, that means you like your electrons more. That means they're less likely to give them up. So nitrogen is going to be acting like a base. So push electrons, just attack right here. And so now, in 2 steps, they're going to be forming that. Right here, we're going to be forming something called an ammonium ion or something like that. I think that's what it's called. And so now we have a charge. Now we formed a delocalized charge. So a delocalized charge means we could form resonance structures. So honestly, I'm not really sure how to form the resonance structure here, but I just know that it's gonna look something like this. I don't know how the arrows work. I know like if you push the arrows here, right, you'd have it there. This is something I'm even a little bit confused about. I'm not gonna lie. And then like imagine like you start like I feel like this is how I'd be thinking about it. Like if you were to like imagine if this pushed it here, right? You would have whatever. Yeah, yeah. Now we have this charge right here, and so yeah, this is definitely not right. But this one, the third one is definitely right because imagine if you pushed it's right here. Yeah, that would be definitely right. I'm not sure about this one though because yeah, so this is the correct drawing. I don't wait. Yeah, this is the correct drawing. There's no lone pairs right here. I think that's why I drew it wrong the first time. Yeah. So this is it. Um. Damn. Yeah. So if we were to push that here, this would be pushed onto here. So this is why this is fine. Okay. Okay. Bet. That one's fine. Okay. This one is like low key. Like I'm not gonna draw the arrows for this. I'm gonna just like show you how it would look. Like, oh, this is OD. Yeah. There's only one arrow right here. And then this one will be shit. I don't really know. Damn. But if we're gonna have it somewhere on is the it's gonna be on the carbon. I just don't know how it's gonna look honestly. Uh, damn. Uh, let me just look at my notes. Yeah, it'll look like that. It'll look like this. I don't know how it happened though, but it would look something like that. This is all the correct resonance structures. I don't know how you got the middle one, but honestly, if you like move it, I feel like if you were to move, yeah, if you were just to move it here, yeah, if you were to just move there, you would just get it. Yeah, you would get that structure. So I guess I mean I'm gonna ask my teacher honestly how to get this. Yeah, so which now we were almost done. We're basically almost done. We just want to figure out like which which structure looks like the product we want. So if you want an amide, right, which is something like this, which one looks like that? It looks honestly like this one, whatever like the double bond is. It looks something that looks more like the answer. So we're just gonna deprotonate it. What are we gonna deprotonate with? We're gonna deprotonate with what's in excess in the flask, right? Oh, this should be a hydrogen right here. Yeah. Okay. We're gonna deprotonate with what's in excess in the flask. So we have a lot of water, right? So deprotonate. I don't know. Oh, I picked the wrong one. It's fine. We're gonna deprotonate with water and bonds in the middle. I lost points on my exam for this shit. I used to always think it should go here. I lost points for that. It's in the middle, and then right here, right there, bond in the center of the bond, and yep. And yep, that's it. And now we're gonna regenerate the base catalyst or the acid catalyst, which is hydronium. Honestly, just put this video in 2x. I don't know. I'm taking a little bit too long explaining this, but yeah, that's really it. Let's see. I'm pretty sure that should be the answer. Yep, that looks correct. Show the. I don't know. There's a double on here. Yeah, that's it.